Hi, my name is Mary Moore, and today I will be talking about how to create, me, a metahuman. To create my digital self, first I needed a high-quality 3D scan. I used Polycam, a mobile app. I tested multiple scans to determine the best one. After some trial and error, I exported my best scan as a GLB file to refine in Blender. Once I had my scan, I brought it into Blender for cleanup. Raw scans often contain unwanted geometry, so I had to refine the mesh to remove extra data. I used Blender's Sculpt mode and the lasso trim tool to simplify the process. I also set up dual monitors, one showing the mesh with the skin and the other showing just the wireframe mesh, to help ensure accuracy while editing. Although the lasso tool sometimes struggled to select certain areas, with patience and multiple attempts, I was able to clean up my face scan and export it as an FBX file, ensuring that both the mesh and the materials were included. Bringing the cleaned up face mesh into Unreal Engine 5 was a bit of a challenge. At first, I had the wrong plugin installed, which took me a day and a half to figure out. Once I had the correct MetaHuman plugin, I ran into another issue. My texture map wasn't appearing. After troubleshooting and re-exporting from Blender numerous times, I discovered a hidden folder with a FBM file. By renaming it to a PNG, I was finally able to retrieve my missing texture. And there we go, there's the texture map. I went back into Unreal Engine and I imported the texture map. I then threw my face onto the Unreal Engine map, rearranging it so I could see it better, and then I dragged the texture map onto my face there. And as you'll see in a few seconds, it'll prepare the shaders and my face will finally show up. To begin, I accessed the control panel by pressing Ctrl and the spacebar. From there, I searched for and added a MetaHuman identity to my project and renamed it for better organization. After adding the MetaHuman identity, I clicked on it, which opened a new window. This is where I imported my reference face scan. I then aligned and adjusted the face with the plane to ensure it matched the underlining structure. With my face selected, I clicked on Track Markers Active Frame. This tool automatically detects and places green tracking points across key facial landmarks such as eyes, nose, mouth, and jawline. These markers help Unreal Engine understand the structure of my face and create an accurate 3D representation. You can zoom in and manually adjust these markers to better align them with your real facial structure. Once the tracking markers were properly adjusted, I clicked on MetaHuman Identity Solve at the top of the interface. This process analyzed the placement of the markers and refines the facial structure, generating a 3D model that closely resembles my face. It essentially maps the captured data onto a MetaHuman-compatible face rig, preparing it for final adjustments and integration. After the solve process completed, I was presented with two views. View A was the gray face model. This is the generated 3D mesh of my face, showing the structure and proportions derived from the tracked markers. View B is the imported face texture. This is the original image or scan I imported. At this stage, I could overlay these two views to compare them. This overlay allows me to check how well the generated mesh aligns with my actual facial features. If needed, I could go back and fine-tune the tracking points for better accuracy. Once everything looked good, I processed the final step by clicking Mesh to MetaHuman. This feature automatically converts my custom 3D face mesh into a fully rigged MetaHuman character. The process applies a MetaHuman identity skeletal mesh, which means my face is now compatible with MetaHuman's advanced rigging system. This ensures my character can be animated with high-quality facial expressions and body movements within Unreal Engine 5. With my base MetaHuman ready, I moved into MetaHuman Creator to refine and customize the details. I started by fine-tuning my facial features, adjusting the shape of my nose, cheekbones, jawline, and lips to better match my real appearance. While MetaHuman doesn't provide an exact one-to-one replication, its powerful customization tools allowed me to get as close as possible. Next, I worked on skin details, modifying the skin tone, roughness, and the subtle imperfections like the pores and blemishes to make it look more realistic. I also adjusted my eye color and the brightness, ensuring my eyes had the right level of depth and realism. For hair and eyebrows, I browsed through the available hairstyles and picked ones that best resembled mine, adjusting the color and strand density for a more natural look. Once the face looked right, I moved on to clothing and body proportions. I chose an outfit that fit my style and adjusted the character's height and body structure to align with my real-world physique. This step was one of the most exciting parts of the process. It was incredible to see my digital self take shape with realistic details and lifelike animations. With my custom MetaHuman finalized, I was ready to bring it into Unreal Engine 5 for animation and integration into my project. To start, I opened Unreal Engine and loaded my project. From there, I needed to bring in my MetaHuman, so I accessed the Quixel Bridge. In Quixel Bridge, I navigated to the MetaHuman section where all my previously created MetaHumans are stored. I clicked on my MetaHuman tab, found the one I customized, and then clicked Download to bring it into the necessary assets. Once the download was completed, I hit Add, which imported my MetaHuman into my Unreal Engine project. Now that my MetaHuman was available, I placed it into my scene. To make my MetaHuman talk, I needed to add an audio file. Now let's generate the facial animation from the audio file. In the content browser, I right-clicked and I went to MetaHuman Animator and selected MetaHuman Performance. I then named the new animation file and double-clicked it to open. In the new window, I changed the animation source from depth footage to audio, selected the dialogue file from the drop-down. This is the file that I uploaded. Now I need to assign the correct facial control rig to the MetaHuman. In the search bar, I typed face and selected the face control board for the MetaHuman. I then assigned the MetaHuman's face to preview the animation. Once everything is set up, I click Process and Unreal Engine will generate the lip sync animation. Now that the animation is processed, I can play it back to test it. I pressed play and I was able to see that my MetaHuman was speaking with the accurate lip sync animation. Once I was happy with the results, I exported the animation as a final asset. I clicked the export animation and named it. I made sure to select my MetaHuman's face as the export target, and then I clicked Create to finalize the animation. Next, I created a cinematic sequence to showcase the animation. I right-clicked on the content browser and went to Cinematics, and then Level Sequence and named it. Then I double-clicked the sequence and opened it. I clicked Add Actor to Sequencer and selected my MetaHuman from the list. At this point, I removed the control rig tracks to keep things clean. Next, I set up the camera. I added a camera to frame the MetaHuman properly, and then I adjusted the focus and lens settings for cinematic look. Now I just need to add the audio and animation. I added the audio file to the sequence and added the lip sync animation track, and then assigned the file that I had for the animation. When I press play, the MetaHuman speaks in perfect sync with my audio file. To create the blinking animation for my MetaHuman, I manually keyed a series of blinks with varying intensities in the sequencer. I adjusted the blink curve values to around 0.8 to ensure a natural eye closure without looking unnatural. After setting keyframes along the timeline, I repeated the process to establish a natural blinking rhythm. For the eye movement, I selected the control center eye in the facial control rig and disabled snapping to allow for smoother, more organic motion. I then manually keyframed subtle shifts in the eye direction at different intervals to simulate natural eye movement. Once both the blinking and eye movements were complete, I baked the animation sequence and integrated it into the MetaHuman's animation blueprint. And just like that, I rendered out my own MetaHuman.